So when I came across your profile, I was really interested because we'd been through some tutors in our area that just weren't a perfect fit for Lou. And I was a little hesitant to go on Skype and try it because I like the one-on-one. But we found that it was a really great fit for Lou, that you connected with him. And since Lou really wants to pursue a career in business, it was important for him to lay the basics of math. And he wasn't getting that where he was. So I feel like you've appealed to both my two oldest kids, and I'm guessing that my daughter will fall right in line in the future. Awesome. My oldest son's, as you know, is more creative. He's a creative thinker, and he's not going to pursue a vocation that requires math as much as Lou. So when Lou wasn't quite getting it for school, we knew that we needed another alternative, and we're so happy that we found you. We feel really fortunate, and it's been seamless. You've been great. And as far as scheduling and everything, you've been really flexible, which we've needed with Lou working and doing sports and that kind of thing. So thank you.
Yeah. Anything on your end?
Yeah, it says it's recording, so we should be good.
All right, very good. All right, so hey everybody, this is Dan from SageMathTutoring.com, and here I have Lou and Kit, who are fantastic people who I've been working with for a long time. And basically, I just want to showcase what like a tutoring session with me on Skype looks like. That way, people are familiar with how it works and what it looks like and what to expect and all that stuff. And I think probably we'll dive right into the session pretty soon. But anyway, Lou and Kit, welcome to the world.
Thanks. Thank you.
Welcome to the YouTube channel. I don't really know much about building YouTube, but I kind of just started, with the YouTube channel, and it's pretty cool so far. I like it so far. But anyway, so Kit, I just want to introduce you real quick. Lou, I think we should get going right away and just get started, and let's rock and roll and see how much we can accomplish today.
Okay. All right. Cool.
All right. So what do you have for me, Lou? Wait, so I'm sorry to hear about the poison ivy. What were you doing? Just going through the woods and stuff?
Yeah.
Tails on a fair coin, absolutely yes. That's the classic sort of 50% chance situation. So beautiful job with that. Piece of cake. Next, suppose the area of a square is that. What's the perimeter of the square?
6.
So, yeah, I mean, basically, we're going to want to remind ourselves of what the area of the square, of like any square is. Now, they say that this is the area of a square. So I'm just going to write area. We'll say it's the area of our square. Because it's the one that we're focusing on, right? Now, the bottom line is, let's just focus over here for a second, though. The area of any square is such that it's going to be side squared. Now, what I mean by that is, in any square, you have a side length right here, and you have another length that's the exact same length, so we're going to call that S. And this is not to be confused with the number 5. This is the letter S. And of course, this side is S, and this side is S. So we know that it's the case that for any square, the area of a square would be side times side. In a way, Lou, as you probably recall, it's really length times width, right? But it just so happens that it's a square, so the side lengths are the same. So this is going to be perimeter equals this side plus this side plus this side plus this side, right? And therefore, the perimeter of literally any square in the universe is going to be 4 times S, okay? So it's that basic foundational concept that you need to be familiar with in order to figure out the answer to the problem at hand.
Yeah.
They basically tell us that we have a square over here where the area is x, squared minus 6x plus 9.
Yeah.
And that's what you get when you multiply something times something else. Would you agree with that?
Yeah.
So the question is, what times itself equals this?
What times so equals?
Yeah, and I'm going to give you a hint though. You have to factor
Mhm.
this. And at this stage in the game, anytime you see these like quadratic trinomials with an exponent of 2, yada yada,
Mhm.
there should be a part of you that feels a little tempted to just go ahead and factor it just to see what it would look like. You know
Yeah.
what I mean? Now, do you remember what that becomes when you factor it? I'm going to write it again over here. It's minus 6x plus 9. Do you remember that it's something along these lines, right? Where it's going to be x and x over here.
Yeah.
Yeah, but the question is what goes here and here?
Hmm. I do
Yeah.
not.
Yeah, it's all gonna come flooding back to your memory, I guarantee it.
Mhm.
So I'll give you a little push. Basically, you're looking for factors of 9,
Mhm.
that when you add them together, you get a negative 6. So what are some factors of 9 in general? I'll get you started. 1 and 9, right?
2, 3 and 3.
Yeah, 3 and 3 totally do it, right?
Yeah.
Which of these two pairs are the most tempting?
3.
Exactly. Now, is it going to be positive 3 or negative 3?
Negative 3.
Good. It's going to be negative 3, negative 3. So, in other words, x squared minus 6x plus 9 factored gives you x minus 3 squared. So can you therefore see that x minus 3 squared is really the same thing as x squared minus 6x plus 9?
Yeah.
And would you agree, therefore, that this is literally going to be x minus 3, and this is going to be x minus 3?
Mhm.
And that's how you would get the area.
Mhm.
Here, it would be x minus 3 times x minus 3. That gives you the area of the square, right?
Yeah.
So my question to you is, what is the perimeter? Seeing as how the perimeter is always 4 times the side length, what is the perimeter of this square? And there's still going to be x's in there, just so you know.
Would it be 4x minus 12?
Yes, exactly so. Beautiful job. So you correctly realize you either used this equation, which is a fantastic idea,
Mhm.
or you recognize that, okay, well, this is x minus 3, this is x minus 3, and then you just added it all up, and absolutely you would get 4x minus 12. That's the answer to that one. You have any questions about that?
No.
That's how that works. Moving on. 3. So, yeah, we have 4 radical 7 plus 8 radical 63. Okay, so I could already see there's a few concepts I want to talk to you about before we dive into this.
Mhm.
All right. Now, as usual, I'm going to sort of set it off to the side. I'm going to give you a crash course and a
Okay.
couple other concepts, and here are some of the concepts. One is, I don't know, the fact that anytime, I'm going to call this just the concept section. Now, I want you to know that everything I say over here is not immediately related to this problem. It's separate problems, separate situations that illustrate the concept.
Yeah.
If I had 5 radical 2 plus 3 radical 2, that's essentially the same thing as something like 5 times the number x plus 3 times the number x, and therefore it would become 8x,
Mhm.
right? Because this is just some number. Radical 2 is some number. It's like 1 point something. So
Yeah.
this is really 5 times a number plus 3 times that same number. So of course, if we were to like combine that, it would become 8 times the same number in the exact same way that this became 8 times the same number over here. You got that? So that's very important to understand just in general when you're simplifying radicals and adding radicals and things like that. So that's one concept you need to be familiar with. Another concept you need to be familiar with is this one, where basically most math teachers will say radical a times b could hypothetically be split apart such that it's radical a times radical b. Okay?
Yeah.
Now, occasionally you might have to go in this direction and kind of perform that splitting action. And occasionally you might have to go in this direction where you have two radicals and it actually benefits you to multiply them together and just put a single radical over the product. So these are things to keep your eye on in general. Now, I'm going to say for now, though, that there is really one more concept that, in my opinion, would be very helpful for you to remember, and that is the concept of perfect squares. So we're going to do a little dividing line. So these are all the different concepts I want you to remember. The other one is perfect squares. Perfect squares are like the following numbers. 1 squared equals 1, 2 squared equals obviously 4, 3 squared equals 9. You know, so you know by now
16.
these deals at a certain stage in experience and or skill, you are going to very effectively memorize these or have these memorized. And it'll be like a no-brainer, like where, for example, you might spot the number 49 and there's going to be a part of you that's going to be like, okay, well, that's a perfect square, right? These perfect squares end up becoming famous in your mind over time.
Yeah.
Now, I'm going to just make sure that there's green around the numbers that are actually perfect squares. Now, there's multiple ways, and you're going to see why I'm doing all of this in a moment, but there's multiple ways of tackling the problem that we have been given. I'm going to give you a way that, in my opinion, is going to be the quickest and potentially most easy to understand way. All right. It's not necessarily the way that the teacher wants you to learn it, but here's a way that would enable you to do this quickly. So basically, they want you to add these two. They want you to simplify 4 radical 7 and 8 radical 63. Now, you're not able to do that because, like in this situation, remember 5 radical 2 plus 3 radical 2?
They need to be the same.
Totally. The radical needs to be the same because 5 radical 2 and 3 radical 2 over here are what we refer to as like terms. Right? You've heard that before. Anytime you have like the same kind of number that's attached, you call it a like term. Well, these are not yet like terms. So the trick is to ask yourself, can I force them to be like terms? Now, it so happens there's nothing you can do with this radical 7. This radical 7 is as broken down or simplified as it could be. Now, what I would strongly advise is taking this radical 63 and simplifying it. Now, before I do that, I'm going to rewrite the 8, but I want to split that radical 3 into 2 separate things, like factors, basically. I want a factor here and I want a factor there. Now, one of the factors I want to be a perfect square number, and in fact, I want it to be the largest one I can find on the list. So I'm going to start backwards. So is 81 a factor of 63? You tell me.
No.
Too big, exactly. What about 64?
No.
What about 49?
No.
What about 36?
No.
Not. What about 25?
25. No.
What about 16?
Maybe.
Yeah, good call. Here's the deal. If 63 is odd, I'm going to give you a little trick of the trade. If 63 is odd, which it is, That
Yeah.
means it literally has no even factors.
Oh, okay.
For now, I just want you to take my word for that.
Yeah.
So 16 doesn't work, right?
9.
What about 9?
Let me see. Yeah.
Very good. 9 is our candidate. Now, once again, Lou, notice how we started from the bigger ones. That's important. You always want to scan the larger ones first and
Yeah.
then stop once you've stumbled upon it. And we have stumbled upon it.
Mhm.
So it's 9 times what gives you 63?
9 times 7.
Very good. So we have that. We still have our 4 radical 7 over here.
Mm-hmm.
And yeah, and you might be asking yourself, well, why did I do that? Well, you're going to see in the next line, we're going to rewrite it as 4 radical 7 plus 8 times something. But what is radical 9?
Radical 9 is
Like, what's the square root of 9, basically?
3.
Totally. So this is really just 8 times 3 times radical 7.
Mm-hmm.
So on the next line, it's 4 radical 7 plus 24 radical 7. And then you do the, what I like to call the kill shot. What is the final move right now?
To add them together and make it 28
Yes.
To the power of 7.
Very good. Any questions with that?
Nope.
All right, so before we move on, I want to give you a little practice problem. I'm going to leave some of this here. And I know we want to kind of move quickly through this thing. But it's also important, of course, that you internalize these things.
Mm-hmm.
So do me a favor. All I'm going to ask you to do is to simplify this number. And we will move on after you do that. Asking yourself, what factors, are there any perfect square factors of 72, starting from the big ones and then moving up?
Yeah. So wouldn't 72 divided by 9 work? Or 9 times
I agree that 9 happens to be a perfect square factor of 72. So good job. I would commend you for moving in the right direction at the very least.
Mm-hmm.
I will say it's not the largest perfect square factor. So if you were to start from 81, does that go into 72?
No.
Exactly. What about 64?
Oh, wouldn't 36 go into 74 or 72 twice?
Exactly so. So I would focus on that one.
Hmm.
Yeah.
Hmm.
Yeah, well, what's the square root of 36?
6.
Good. And what does this become right here?
12.
Well, what is 7 times 6?
7 times 6 is, give me a second, 42.
Very good. Now, Lou, to be sure that we're clear,
Mhm.
you're not able to multiply this 6 times the radical 2.
Yeah.
Any number that's like underneath the radical,
Mhm.
like that, you have to kind of keep it there, you
Yeah.
know, when it's simplified at least.
Mhm.
And we already did simplify it because we found that perfect square factor of 72. So we have 42, radical 2. That's the final answer. Does that make sense to you?
Yeah. Tangent. I don't know what else.
Tangent theta equals opposite
Oh yeah,
over adjacent.
adjacent.
Does that ring a bell to you?
Yeah.
All right, so I'm going to leave that one to you. What is the answer when it comes to that one?
Tangent of an angle is equal to the ratio of opposite side over the adjacent side.
Yes. Very good. Any questions with that?
Nope.
All right. Do me a favor. Actually, don't worry about it now. I was going to have you resend some of this, but actually, I don't need you to. 1 second.
Oh, okay.
Let me just find you real quick. What number are we on? Remind me of that if you don't mind.
33.
33. Okay. Okay, they say factor the expression. Let's see, 8 squared plus kf minus 2f squared. Ugh, that's awful. That is just terrible.
Yeah.
Whew. How do you factor that one? Ugh. So, yeah, let's see here. What could we do with that one? Oh, it's k squared. That actually changes things. Okay, that's much better. Okay, so here's the deal. I know this is weird looking, and you're maybe not used to seeing things that look like this. I mean, you're probably more used to seeing things that look like x squared plus 4x.
Yeah.
You know, minus 5 or something, in which case you would factor that into this. Where you'd ask yourself, okay, well, what factors of -5 are such that when I add them together, I get a positive 4, you know? This is a little bit different in that there's 2 variables. You have a k variable and you have an f variable. Here's the way that I'm going to suggest going about this, and this might be different than the way that your teacher might be teaching it, but as usual, I'm just going to give you what I perceive as the easiest and least confusing way, and that is to actually assign a number for f temporarily. We're going to temporarily do that. F in our world is going to equal 3. Just temporarily. And what that means is I can rewrite this equation as k squared plus 3k minus 2 times 3 squared. What is 3 squared? You tell me.
3 squared is 9.
9. And what's 9 times 2?
9 times 2 is 18.
So this is going to be temporarily
18.
negative 18, exactly so. You got that?
Yeah.
So let's factor this now. And we both know it's going to be something like this, like K and K, but what is it going to be over here? What factors of negative 18 are such that when you add them, you get a positive 3?
Oh, okay. Negative 18.
And I'll give you a little boost. 1 times 18 gives you 18. 2 times 9 gives you 18. 3 times 6 gives you 18.
Yeah.
Anything else?
I don't think so.
All right, which pair? There's 3 rainbows. Which pair stands out?
Isn't 4 times? No.
Yeah, not 4.
Which pair of rainbows? We're trying to find 3, or we're trying.
Yeah, so we want factors of negative 18.
18. That
when you add them, yeah, you get this 3 over here.
Okay, yeah.
Now, let's remember.
They're negatives, right?
Well, let's remember that factors of negative 18 are such that one of them needs to be positive and the other one needs to be negative, right? So what did you just say?
I asked if they were negative.
Yeah, good question. One of them has to be positive, the other one's negative, right?
So it would be negative 6 plus 3.
Well, positive 3 plus negative 6.
Or positive 3 plus negative 6, yeah.
Yeah, so positive 3 plus negative 6 would give you a negative 3. Is that what we're looking for?
Oh, no, we're looking for a positive 3.
Good. So I like the fact that you chose this 3 and 6 pair, but what do the signs need to be with regards to each number?
I don't know.
So you have 2 to choose from. It's either going to be positive 6 plus negative 3, or it's going to be negative 6 plus positive 3. Which one would give me a positive 3?
3 plus negative, or 6 plus negative 3.
Very good. So would you agree that that's what we're looking for, right?
Yeah.
Okay, so we have plus 6, and we have minus 3 right there. Any questions about that at all?
No.
All right. So in a way, we're kind of done. But here's the problem. We used 3 and substituted that in for f. Right?
Yeah.
So in the final move, we have to ask ourselves, what are these numbers in terms of f? Let's start with the right. We have k minus, you ready?
Yeah.
F. Do you see that? Because 3 is f.
Is f, yeah.
Right?
And you get k minus f as well for the other one.
Well, hold.
K plus f, right?
No. Just as long as you understand this one, right?
Yeah.
You feel totally good there. Now 6 is 2 times 3. Would you agree?
Yeah.
So this is going to be plus what?
Plus 2.
2 what?
2,
3 is equal to f. Would you agree?
Yeah.
2 times 3 gives me 6, yeah?
Yeah.
2 times what? Because we're writing in terms of f right now, yeah?
Yeah, 2 times 3. No.
Well, once again, 3 equals f. And we're doing this final move where we replace all the 3's with an f. So what does this become?
Oh, 2F.
Very good. Plus 2F. Now, here's the deal, Lou. This problem is unavoidably weird and unavoidably confusing.
Yeah.
In my opinion, the best way to make it the least amount confusing is to just temporarily replace F with a normal number,
Yeah.
factor it as normal, and then in the final move, replace,
Yeah.
bring F back in there. If F equals 3, well, 6 is 2 times 3, so this is going to be 2F. If F equals 3, well, this is K minus 3, so this is going to be K minus F. Do you have any questions about that?
No.
All right, you got that written?
Yeah.
All right, good job. This next one I'm tempted to let you do. Yeah, so it is a little tough because 6 is a coefficient that is, greater than 1. So it does make it a little bit tricky. I'll tell you what, I'm going to let you do this, but I'm going to do a separate problem that is similar to this one real quick.
Okay.
And I'm going to think out loud when I do it.
Okay.
Which would enable you to see the thought process required for this particular problem. So we're just got to pull a practice problem real quick. Factoring trinomials with lead coefficients. All right. Okay, so here is the method that I'm going to propose for these kinds of quadratic trinomials. And note how this is somewhat of a different situation because I think you're probably a little bit more used to like x squared minus x plus 2, where there's this invisible 1 right there. And that is always going to be a somewhat easier situation. When you have a 2 in front, that makes it a harder situation, okay? So we are going to focus on what do you do when you have a leading coefficient that's like greater than 1. Well, what I would propose is getting the magic number first. And the magic number is this number that you get when you multiply the 2 times the 5. That is, of course, a positive 10. All right? I'm going to put a little box around it. It's a positive 10. Now, then you ask yourself, what factors of positive 10 are such that when I add them, I get a positive 7? You tell me. We have 1 and 10. We have 2 and 5.
2 and 5.
3 and anything?
No.
That's it.
Yeah.
Which pair stands out to you?
2 and 5.
Very good. Would you agree that positive 2 times positive 5 gives you 10, and positive 2 plus positive 5 gives you 7, right?
Yeah.
So therefore, and here's the crucial move, you take this middle term and you explode it. All right? It's like dropping a bomb in the middle term. I've even heard this method be called the bomb method. So I'll keep the rest in red. So this would be 2x squared plus, I'm going to explode that middle term, but let me just write this in red. Now it's 2x plus 5x. You see that? So I took that middle term and I exploded it out like that, right?
Yeah.
So that's a worthy step. Then what you do is you do something called factoring by grouping, where you pay attention to the first 2 terms first, and then pay attention to the next 2 terms next. Now, I know that you probably remember some of this, Luke, because we've done this before.
Yeah.
Let's focus on this. What is the greatest common factor of these 2 terms?
Factor out of those two terms.
Well, let's ask ourselves, does 2 go into both of those terms?
Yes.
Absolutely. So I'm actually just going to write this. We're going to factor out the GCF. So I'm going to write 2. Does x go into both of those two terms?
Yes.
Very good. So let's kind of figure out, okay, we just factored out a 2x from this term and this term.
Mm-hmm.
So 2x times what gives me a 2x squared?
2x times 2x.
2x times 2x would give me a 4x squared.
4x. So 2x times times 2
2x times what gives me this?
2x times the square root of 2.
All right, so that's incorrect. So basically, anytime you multiply an x cubed times x to the 4th, you keep the variable and then you add the exponents, right?
Mm-hmm.
So would you agree that 2x kind of looks like 2x squared, right?
Mm-hmm.
But we need to multiply what times that 2x to get this exponent of 2? And let's also keep in mind there's an invisible 1 over there, right?
Yeah.
I'm just going to tell you. So it's x. That's what you have to do. All right. And I want to make sure that you understand why before we move on. So 2x times x, well, think about it. You have 2 times x times x. What is x times x?
X times x is 2x.
Nope. X plus x is 2x. That's true.
X times x is like
X squared.
x squared.
Yeah. So we're going to go over that right now because this is really, really important and I cannot move on until we understand this. So basically, anytime you raise something to a power, like, for example, imagine we have 5 to the 3rd power.
Mm-hmm.
That really means 5 times 5 times 5. Would you agree with that?
Yeah.
If I raise 6 to the 2nd power, would you agree that that's really just 6 times 6?
Yeah.
If I had x squared, would you agree that that gives me x times x?
Yeah.
Imagine I had 3 times x squared. Well, wouldn't that just be 3 times x times x?
Yeah.
So do you understand, therefore, how 2, this right here, 2 times x is really 2x squared, right?
Mm-hmm.
Do you understand, therefore, that this 2x times this x gives me 2x squared?
Mm-hmm.
Any questions at all about that?
No.
All right. Now, 2x times what gives me 2x?
2x times what gets you 2x?
Yes.
2x times oh, you're talking about like what times x equals 2x, or
So I'll do the little distribution line. So we already figured out that 2x times x gives me 2x squared.
yeah.
Now we want to know 2x times what over here gives me 2x?
Oh, 2x times times x to the 2nd.
That's incorrect. So what you just said is that 2x times x squared gives me 2x. But the reality is 2x times x squared gives me 2x to the 3rd. That's not what we're looking for, right?
Yeah.
Yeah, so 2x times what gives you itself?
2x times x, right? Wouldn't
That's incorrect. 2x times x gives me 2x squared. And in fact, we already covered that. 2x times this x gives me 2x squared. So I'll ask one more time, and if you don't get it, it's fine.
2x
I'll give you
times
the
1.
Yes, very good. It is
Oh
1.
my gosh.
Very good. Yeah, so I think
That
you
was a little bit of a brain.
are distracted, yeah, by either poison ivy and or summer brain and or a combination of the two.
Yeah.
So, yeah, so any questions about just that part?
No.
All right, very good. Now, here's the deal. If you factor by grouping, you should end up with the x plus 1 over here as well.
Mm-hmm.
So the question is, what's the GCF over here?
Greatest common factor. 5?
Totally. So it's a plus 5. Any questions at all about that?
No.
Do you see how this is already set up? 5 times x would give you 5x, yeah?
Mm-hmm.
5 times positive 1 would give me a positive 5, right?
Mm-hmm.
Then the question is, well, what do you do now? Well, basically what you have to do now is you have to split this into 2 parentheses. This is the final move. You make one of the parentheses x plus 1. In fact, I'm going to put an underline underneath that.
And then the other one is 2x plus 5.
Exactly, dude. That is how you use the bomb method to factor quadratic trinomials that have leading coefficients, okay?
Mm-hmm.
So now there's multiple ways of doing it. Some teachers would teach you this method where you draw like a 2x2 box and do it from there. But this is a way that I was taught, and it really stuck with me, and I really, really like it. So I'm going to leave this here. I want you to work through this one, and I want you to come up with the magic number. What is 6 times negative 35? Get that magic number.
Negative 210.
Yeah, negative 210. Right?
Yep.
Now, I will say there's a lot of factors in negative 210.
Yeah.
And I'm gonna just help you with this part in the name of saving time because we're almost done.
Yeah.
So we have 1 times 210. Obviously, that would work. You know, 2 times what?
105.
Exactly. But one thing that stands out to me, Lou, that I think you'll agree with is that, you know what else works? 10 times 21,
Yeah.
right?
Mm-hmm.
All right, so we'll just leave it there. Ask yourself which pair, one of them's got to be positive, the other one's got to be negative. Which pair would add together to give me an 11?
10 times 21, or 10 plus 21.
Good. Which needs to be positive? Which needs to be negative?
Positive needs to be 21. The negative needs to be 10.
Very good. So would you agree that we could therefore rewrite this as plus 21g minus 10g minus 35? So we took 11g and we broke it apart. And I want you to please destroy this problem right now. And if you have any questions, just let me know. If you hit a speed bump, let me know.
So would it be 6G, parentheses G plus 1 plus 10 parentheses G plus another one?
Yeah, I don't believe so.
Not
Let's
one,
start
right?
with the 2 on the right. Sometimes it's good to start here because factoring these might be a little easier than factoring these because these are less complicated.
Mm-hmm.
So what is the GCF of negative 10G and negative 35? We're going to call it negative. Negative what? What goes into 10 and 35? Well, does 5 go into both? Let's start there.
Yeah, yes.
So you could always experiment and just be like, all right, let's see what happens here.
Yeah.
So imagine it's negative 5. We'll just see what happens. Negative 5 times what gives me negative 10G?
2.
2 what?
2G.
Good, 2G. Negative 5 times what gives me a negative 35?
7.
Positive 7. And these, 2G and positive 7 do not have any common factors other than 1.
Mm-hmm.
So that's how you know that we have properly extracted the GCF from negative 10G and negative 35. Any question about that?
No.
So remember, Lou, how I said if all had gone well, you should therefore be able to write the parentheses over here.
Mm-hmm.
You should be able to, because that's kind of the point of this whole thing, is to get these two parentheses to match.
Yeah.
So we kind of made things easier on ourselves. Now we could focus here. We want to ask ourselves, well, what's the number that's lingering here, right? In other words, what number times 2G would give me 6G squared?
3 squared.
3 squared is 9.
3 squared.
All right, so Lou, I'm going to ask you a different question, not to interrupt your train of thought, but what number times positive 7 would give me a 21?
3.
3 what?
3G.
Yes. Any question about 3G times 7 would give me a positive 21G. Any question about that?
No.
And now let's just double check.
It also works on the other one.
Yeah, does 3G times 2G give me 6G squared?
Uh-huh.
Absolutely. Kill shot time. This is all you.
3G minus 5.
Yes.
And then 2G plus 7.
Amazing. You rock. Obviously, Lou, probably would be great to get more practice with that.
Yeah.
But as long as you're refreshed, as long as you're remembering, that's really mostly what I care about.
Mm-hmm.
All right.
Alrighty.
All right, well, dude, you're the man, and I will unshare screen. Any questions with anything that we did today?
No.
Kit, thank you so much. Lou did great as usual. And before I sort of part ways with you guys, I just wanted to ask you, what maybe you've appreciated about the tutoring? Has it been convenient? What do you like about the Skype tutoring so far?
So when I came across your profile, I was really interested because we'd been through some tutors in our area that just weren't a perfect fit for Lou. And I was a little hesitant to go on Skype and try it because I like the one-on-one. Yeah. But we found that it was a really great fit for Lou, that you connected with him. And since Lou really wants to pursue a career in business, it was important for him to lay the basics of math. And he wasn't getting that where he was. So I feel like you've appealed to both my two oldest kids, and I'm guessing that my daughter will fall right in line in the future. Awesome. My oldest son's, as you know, is more creative. He's a creative thinker, and he's not going to pursue a vocation that requires math as much as Lou.
Yeah.
So when Lou wasn't quite getting it for school, we knew that we needed another alternative, and we're so happy that we found you. We feel really fortunate, and it's been seamless. You've been great. And as far as scheduling and everything, you've been really flexible, which we've needed with Lou working and doing sports and that kind of thing. So thank you.
Yeah, you're very welcome. And since we're sharing, yeah, I really appreciate you guys. I do appreciate how we've always been able to work out the schedule. You know, it's always like, yeah, because my schedule is crazy too, just like you guys. But you know, we just text each other. We always manage to figure it out. And yeah, so I really appreciate that. Would you say, okay, what? So the Skype clearly works because it's convenient and everything. Is there anything just off the top of your head about me personally as a tutor with regards to my communication style or what have you that you find has, you know, clicked with your two sons? We'll just say those two.
Okay. So for Lou, I feel like when he's losing focus and losing attention, although I'm not in the room the entire time, I'm never in the room, but I've noticed that you're able to reel him back in pretty seamlessly.
Yeah.
You've connected with him, like with his interests and that kind of thing, and kept him rolling through it.
Yeah.
So I've really appreciated that. And I just think that there's a comfort level
Absolutely.
that you bring to the table by making math fun and also making it relatable. Like when you do the problems, it's not just, you know, somebody standing up at a blackboard and writing it out. You've really taken the time for him to like work through it and figure it out on his own, which we're grateful for.
Very good. Well, thank you so much. Yeah, I feel, you know, it's kind of a weird thing because I do like my students in general. And also I will say that it has been a pleasure working with your kids. Your kids are completely unique. And in fact, they're completely different from each other. You know what I mean? In good ways, you know, in good ways. So, so yeah, I again, right back at you. I appreciate, you know, my time with you guys, and it's been seamless for me as well, for sure. So, all right, well, with regards to this week, we're not meeting this week, but I do have it written down. I literally have it on a calendar. So we don't even need to confirm it. It's fine.
Okay, cool.
You know, I'll be waiting next week. And as you know, I'm going to be going away to Europe, and I still definitely want to, I'm gonna consider that like a test run to see how easy that is to just go ahead and Skype from Europe. I mean, I don't see why it wouldn't be. So, but you know, I'm kind of wondering, are there going to be unforeseen speed bumps that I run into? But yeah, my interest is to always work even when I'm traveling, just because I like it, you know, to be honest. And obviously, I want to keep the momentum with you guys.
That's great.
All right, so I will talk to you soon, Kit, and thank you so much. And I really appreciate the recording. I really appreciate the testimonial. I will shoot you guys the link of the YouTube video once I'm done like editing it and everything like that. All right.
All right. Have a good day.
All right. Thanks. Enjoy. Bye.